Every AI image you've seen, every photorealistic face, every impossible landscape, started as television static, pure noise. And that's not a limitation, it's the entire trick. Here's what most explainers get wrong about image generation. They describe it like the AI is painting, choosing colours, placing shapes, composing a scene. It's not. The model never learns to draw, it learns to clean up. And that distinction changes everything about how you understand what these systems actually do. The process is called diffusion, and it works in two phases. The first phase is training, and it's almost comically simple in concept. You take a real photograph, say a dog on a beach, and you destroy it. You add a thin layer of random noise, like grain on old film. And then you add more, and more. You do this across hundreds of steps until the image is unrecognizable, just static. Then you save every step of that destruction as a pair. Here's what the image looked like at step 47, and here's what it looked like at step 46, slightly cleaner. Now you train a neural network on millions of these pairs. Its only job? Given a noisy image, predict what it would look like with slightly less noise. One small step, cleaner. That's the entire task. The network never sees the final clean image during a single pass. It just learns to nudge things one step back towards structure. To generate a new image, you reverse the process. You start with pure random noise and ask the network to denoise it, one step at a time, across maybe 50 or 1,000 passes. Structure emerges from nothing. Edges first, then shapes, then textures, then detail. But here's the piece that connects your text prompt to the output. A separate model called Clip has learned to link language to visual concepts. When you type "a cathedral made of ice at sunset," Clip's understanding of those words biases every single denoising step. The network isn't just removing noise, it's removing noise in a specific direction, guided by your description. One more practical detail. Modern systems like Stable Diffusion don't run this process on full-resolution images. They compress the image into a smaller mathematical space first, a latent space, run the diffusion there, then decompress the result. That's why generation takes seconds instead of hours. It's called latent diffusion, and it's the engineering insight that made this technology usable. The reason starting from noise works better than drawing pixel by pixel is subtle but important. Noise gives the model freedom to explore the full space of possible images. Drawing sequentially locks you into early decisions. Diffusion keeps every option open until the very end. If that was useful, subscribe. New explainer every week. I'm Ariella.